Okay, so now we actually did not get interrupted by anybody at the end of the last video. And at this particular point, we're going to work our study toward histograms, okay? For most of the work you do in this book, you will use a histogram to display the data. It's a very common source of data display. One advantage of a histogram is that it can readily display large data sets. That's a huge advantage. Anytime you get 100 values or more, you really want to be sure to be using a histogram. A histogram consists of contiguous adjoining boxes or bars. And remember before we said that a bar graph, you have to keep them separate. And then we said in the future, we'll talk about histograms. Well, the future has arrived. Here is the histogram, and you have adjoining boxes or connected boxes. Same thing, horizontal, vertical axis. Labeled with data represents, for instance, and this is for the horizontal one, it could be distance from home, it could be favorite color, whatever. And the vertical axis is the frequency or the relative frequency. So either exactly how many there are, or in the case of where we convert it to a percent or a decimal, the relative frequency. So remember, F stands for frequency, N is the total number in the data set, and RF is relative frequency. CF, they didn't list it here, but CF is cumulative frequency. So with those reminders in place, let's begin to look at, whoa, a whole lot of data. All right. This is continuous data because the data is, since the height is measured. So in the 60s, there's 60.5, 61, 61, and 61.5. That's what I'm looking at right here. And then like in the 64 range, I got a whole bunch of 64s, 64 and a halves, all the way through. Now, when we look at this, one of the things I want to note is what the smallest one is, the smallest score, and also what the largest score is. So the smallest data value is 60. Since the data with the most decimal places has one decimal, for instance 61.5, we want our starting point to have two decimal places. In other words, we want to be a little more specific than what they're using for data. They're using 60.5, so we want to make sure that we're spread out a little further so we can capture 60.5 in a real limit or interval. So since the numbers 0.5, 0.05, 0.005, etc. are convenient numbers, we'll use 0.05 and subtract it from 60. So 60 minus 0.05 is 59.95, which is a more precise way, more precise than, say, 61.5 by one decimal place. So it's a little more specific. And the starting point is then 59.95, just under the 60, so that we include the 60. And then the largest value, similarly, would be 74.05. Now, you might say, well, wait a minute, everything I've seen till now has been like 59.5 and 74.5. But because this one goes out to 0.5s already, we want to go out one more decimal place. In other words, this is the tenths place. We want to go out to the hundredths place. And then next, calculate the width of each bar by subtracting the highest minus the lowest, and then dividing by the intervals that you'll think you'll have. And in this case, there are 8 of them, okay? 1, 2, 3, 4, 5, 6, 7, and 8, and I get 1.76. And then what I want to do is just always round that up. You never, ever, ever, ever round down, always up. So we make that up to 2, okay? So there's the rounded up of 1.76 to get 2. So if I just keep going up by 2s, I get 59.95 to 61.95. And then 61.95 to 63.95, 63.95 to 65.95. So you just got to remember here that you're putting a 5 one decimal place past the level of specificity in the problem. In this problem, the level of specificity was tenths. So I want to go 0.5 to the next decimal after tenths, which is hundredths. And that's why I now have 61.95, or better said, 61.95 hundredths, okay? Where does that help us? If we go down and look at the intervals under the heights on the histogram, 59.95 to 61.95 to 63.95 to 65.95, and so on. So I'm coming up with these numbers, 61.95, by increasing my level of specificity 0.5, one column, if you will, past the level of specificity in the numbers I'm given. In this case, it was tenths, so I want to go one column past there to hundredths. And I want to go 0.05 below, 0.05 above when I figure these things out, so that I fit all the specified numbers inside those intervals. That's what it's really all about. So you'll notice here on the histogram that the intervals go to match what we wrote above. And then also notice we do have scales on both of them. Notice that the bars touch each other. Very important in histograms. And you can see why, because histograms are representing these intervals. And there's no gaps between the intervals, so there should be no gaps between the bars. The axes are labeled. Okay? So, this time, example 2.8. Create a histogram for the following data. You'll notice that the level of specificity here is only out to the ones place. So we wouldn't go to 0.95. That's out too far. 0.5 would be fine. Okay? 11 students buy 1 book, 10 students buy 2 books, 16 students buy 3 books, and so on and so forth through here. Because the data are integers, you want to subtract the 0.5 and then add the 0.5, so that gives me 0.5 as my beginning point and 6.5 as my ending point. That's that whole thing about going out one place value further than where they stop at. They are specific, or their level of specificity is the ones, so we go out to the tenths. If it was the tenths, we go out to the hundredths. If it was the hundredths, we go out to the thousands, and so on. Okay, next, calculate the width of each bar. So if you're going to go from 0.5 to 6.5, and we're going to have a total of 6 bars here, then we want to make sure each bar is going to be 1 unit wide. Okay? All right. So we're going to go 3.5 to 4.5, 4.5 to 5.5, and so on and so forth. What we're saying is 6.5 minus 0.5 is equal to 6, and they're going to be, and the width is going to be 1 unit each. We know that, therefore we need 6 bars, which I think you kind of knew already anyway, because there were 1s, 2s, 3s, 4s, 5s, and 6s. The following histogram displays the number of books on the x-axis and the frequency on the y-axis. With a histogram, frequency is always, anything unclear about that? Always in or on the vertical column, the left column. Okay. All right. And actually, drawing the histogram is pretty easy. I mean, you just put the plots up there. It's kind of like drawing the bar graphs before. Okay. Let's talk real limits now for a bunch of ungrouped data. What's the level of specificity here? It's ones. So when we do our real limits, we want to go above and below by 0.5 or tenths. Ones goes to tenths. So the real limits for anything that we would count as a 1 is anything between 0.5 and 1.5. Counted as a 2, anything between 1.5 and 2.5. Counted as a 3, 2.5 to 3.5. In other words, these real limits are any numbers that would round off to a 3, round off to a 4, round off to a 5. And they said here that the frequencies were 2, 3, 4, 2, and 1. So that's what I wrote in the frequency column, or they wrote in the frequency column. As far as grouped data goes, our intervals are going to be 30 to 31, and so on and so forth. But again, their level of specificity is the ones column, so we go out to the tenths column, and our real limits are 29.5 to 31.5, 31.5 to 33.5. And I can't emphasize enough that this is just the range of numbers that would be rounded off to somewhere a 32 or a 33. From 33.5 to 35.5 would be rounded off to a 34 or a 35, and so on and so forth. What would a histogram for each of these look like? Well, here's what your histogram would look like, okay? What we have here is a repeat of what the frequency tables were, and here's your histograms. Frequency, quiz scores. Over here, it's frequency. Notice frequency is always on that vertical axis. And then children's heights by inches, so you're labeling it. And then Also, I want you to notice the difference here. Do you see how the data in the top histogram starts with a 1? And the data in the bottom histogram starts with 30? Do you see this little break here? That's called a break. You can put a little zigzag there or a little gap as shown, and that just means you're skipping a bunch of numbers. That's all it means, until you get to the one you're going to start the table with. Notice there are no spaces between the bars. Never spaces between the bars. Okay? And that's because the scores are connected, so there should be no space in between them. All right. Any questions on these? Now, frequency polygons. Pretty simple. In a polygon, a dot is centered above each score so that the height of the dot corresponds to the frequency. All right, it's a lot like a line graph. I know that sounds complicated, but it's not. It's a lot like a line graph, but the difference is that an additional line is drawn to bring this line graph back to the polygon graph, back to the 0 frequency. Show you what I mean. Okay, we got some ungrouped scores, but this time, instead of trying to figure out the interval over which we would, or in which we would count a particular score, we're going to calculate the midpoints of those scores. Okay? So the midpoints of those scores will go right here. In the middle between 4 and 5 is 4.5, 6 and 7 is 6.5, 8 and 9 is 8.5. If you're looking for a fancy formula, anytime you're going to get the midpoint, whether it's coordinates or the middle, whether it's just be any figuring in mathematically, it's just add them up and divide by 2. So 4 plus 5 is 9, divided by 2 is 4.5. 10 and 11 is 21, divided by 2 is 10.5. So that's how we generate what the midpoint would be. The first graph looks like this. The first set of data, here it is, you can see it. Okay, there's 1 1, there's 2 2s, there are 4 3s, there are 2 4s. Remember, F is frequency. There are 2 5s and there's 1 6. But the big difference, well, we'll get to the big difference in a minute. Over these intervals, okay, notice they still find the midpoint of the interval. So for the first interval, it was 4.5. And if you look at the midpoint of 4.5, it's right up here. The next midpoint was 6.5. And there it is, between 6 and 7. And then 8.5, 10.5, and last but not least, 12.5. The big difference between the frequency polygon and the line graph is this. You're going to bring the lines back to 0. With the line graph, this area here would be void. There would be nothing there. Same here and same down here on the beginning and ends of the graph. But when we get into the polygon feature, we want to include bringing it back to the zeros. All right, that's the last video for this particular lesson.